Hello, this is Frank Baranco speaking. On behalf of my collaborators, Ivy Harvey, Paul Caprio, George Hay, Carl Palmer, and Billy Anderson, thanks for visiting our audio summary relating to our project on thermal desorption treatment of solid investigative derived waste, or IDW, impacted with per and polyfluorinated alkyl substances, or PFAS, supported by the Strategic Environmental Research and Development Program, or SERDP. This project was performed in response to a SERDP statement of need to develop innovative proof of concept approaches for treatment of IDW, such as impacted soils, granular activated carbon, and resins that have been contaminated with PFAS. The technical objective of this work was to advance Department of Defense's current understanding of ex situ thermal technologies, specifically indirect thermal desorption, or ITD, coupled with thermal oxidation, or TO, for treating soil impacted with PFAS found in, but not limited to, formulations of aqueous film-forming foam, or AFFF, manufactured prior to 2002. To address this objective, a hypothesis-driven two-phase pilot-scale treatment regime, referred to as the Demonstration Test Program, was conducted on PFAS spiked and AFFF spiked soils at two different ITD temperatures, 500 degrees Celsius and 650 degrees Celsius, with follow-on exhaust gas treatment by TO. Within the reporting for this project and summarily identified within this audio recording, we present the results of the pilot scale demonstration test program examining the performance of an ITD system and the destruction and removal efficiency, or DRE, of PFAS within the TO when treating PFAS spiked and AFFF spiked soil. Pretreatment and post-treatment soil samples were analyzed for PFAS using EPA-modified method 537 liquid chromatography tandem mass spectrometry, specifically adapted to meet the Department of Defense's quality system manual standards. TO exhaust gas was analyzed for PFAS via EPA method 0010 and method 537 to evaluate DRE of PFAS, as well as analyzing for hydrogen fluoride via EPA method 26A to assess the fluorine mass balance. The demonstration tests show conclusively that at 650 degrees Celsius, the ITD technology will remediate PFAS in impacted soil to a PFAS concentration of less than 1 to 10 micrograms per kilogram, and that a TO can achieve a DRE of greater than 99.9997% for exhaust gas emissions from ITD treated PFAS spiked feed material. Test results also demonstrated that ITD technology effectively desorbs PFAS precursors when treating soils that were spiked with AFFF. The knowledge of how PFAS behaves in thermal or combustion systems is scarce, to say the least. One of the more important aspects of this project was to advance the understanding of whether ITD coupled with TO was capable of achieving irreversible destruction of PFAS-containing IDW, and if other unintentional PFAS degradation products would be formed during the process of thermal desorption and/or thermal oxidation. During the test where the TO was employed and the exhaust gas was analyzed for PFAS and hydrogen fluoride, a mass balance was performed on total fluorine to confirm the destruction of PFAS. Test results conclusively showed the absence of PFAS in TO exhaust gas under extremely low detection limits at part per trillion levels. Moreover, results showed that 99% on average of the molar equivalent of fluorine from the PFAS spiked feed material was evident within the mass balance. These two complementary lines of evidence, when coupled together, definitively illustrate complete PFAS removal and destruction under the conditions tested, which was a primary objective of the project. An ancillary benefit of the project included significant improvements in laboratory sample extraction and recovery methods for EPA method 0010 followed by EPA method 537 procedures. These improvements will ensure the future success of PFAS extraction and recovery from the TO exhaust sampling train, thereby improving future DRE estimates and fluorine mass balance calculations. For additional information on this project, consult our final report available on the CERTA website.